This lecture is on the 4 different levels of measurement. These levels are ratio, interval, ordinal, and nominal. Now these levels of measurement are ranked in a hierarchy, and the higher you go, the greater freedom you have to employ different kinds of statistical tests. So it's important to always use the highest level of measurement available for whatever variable you're dealing with. In addition, being able to identify the level of measurement is important when choosing how to present your findings. Let's start at the bottom of this hierarchy with nominal level variables. Nominal measurement is used when your observations can be placed in mutually exclusive, exhaustive categories. So it must be the case that each observation belongs to one and only one category. Gender, country of origin, religion, and political party are all examples of variables measured at the nominal level. If you think of the word nominal, it refers to name. So we can think of nominal variables as those in which the focus is the name itself and not any quantitative value associated with the name. Nominal level variables have no quantitative meaning associated with them, but numbers are often used in a database to represent them. So for instance, on a survey that asks participants their political affiliation, I might code 0 for Democrat, 1 for Republican, 2 for Green Party, 3 for Libertarian, and so on. In this case, the numbers are used to simplify my database, but there's no quantitative meaning associated with them, so I can't do any statistical tests or any functions that involve addition, subtraction, multiplication, or division with them. So even though I coded Republican as 1 and Green Party as 2, it makes no sense to say that Green Party is twice as much as Republican. And it makes no sense to report the average for political party with a number like 0.5 because this is meaningless. All I can do is count the number of responses in each category and report them using actual figures or percentages. So I might say that 49% of my sample identified as Republican, 49% as Democrat, and 2% as other. Now, in some cases, options for a nominal level variable are not mutually exclusive. For instance, if we ask participants their ethnicity and force them to choose only one response from a list of categories, we're not allowing people who identify with more than one ethnic group to answer thoroughly. This can be addressed by creating the attribute of other and allowing respondents to write in their own answer. This can also solve the problem of having categories that are not exhaustive. For instance, if we force someone to select from male or female for gender, we're not allowing a category for those who identify as somewhere in between or outside of the gender binary entirely. So creating an other category and allowing people to identify their gender any way they want solves this problem. Just above nominal measurement in our hierarchy, we have ordinal measurement. Ordinal measurement also relies upon us having mutually exclusive, exhaustive categories, as in nominal measurement. But in ordinal measurement, we have the additional benefit of allowing attributes to be rank-ordered. That is, there's a sense that one category is more or less than another category. Any numerical codes we use here may have quantitative meaning, but only as far as indicating whether one attribute is more or less than another. A common example of ordinal level measurement is a survey item that asks for a participant's level of satisfaction, and the options are maybe low, coded as 1, medium, coded as 2, and high, coded as 3. While we can say that participants who chose high were more satisfied than those who chose medium or low, we can't say that they were twice as satisfied, or anything like that. Another example is level of education. We might have the discrete categories of high school, some college, college, and graduate degree, and we could say that those who completed college had more education than those who completed high school, but we couldn't say exactly how much more education they had. So we can't use the numbers that we use to code for our attributes, such as 1, 2, and 3, to do any mathematical functions. We couldn't, for instance, calculate the mean or average agreement score or amount of education. So again, we would report our findings in terms of actual figures or percentages. Moving up our level of measurement hierarchy, we now come to interval measurement. Like ordinal measurement, there is an inherent order and an indication of which category is more than or less than another. The difference between interval and ordinal measurement is that in interval measurement there is equal spacing between the categories. So we might have the example of IQ, in which we can say that an IQ score of 120 is 20 points higher than an IQ score of 100. However, there is no true 0 point in interval measurement, so we don't really have an option of 0 as an IQ score. Temperature is another example of an interval level measurement. While we might have 0 degrees as one point on the continuum of temperature points, it doesn't reflect an absence of temperature. And we can't accurately say that 50 degrees is twice as warm as 25 degrees, only that 50 degrees is 25 degrees hotter than 25 degrees. Grade point average is another example, where you have equal spacing between categories, but no true 0. Because of this, we're limited to using only addition and subtraction, and can't use multiplication or division. Now, if we think back to those items on rating scales that ask respondents to rate agreement or satisfaction on a 1 to 3 or 1 to 5 scale, we can arrive at an interval measure if we combine all the different items on a scale to create a sum or average score. So while the individual items on many instruments are ordinal measures, the overall score on the measure can be considered an interval measure. So here's an example of this. This is a copy of the 5-facet mindfulness questionnaire. There are 39 items. The first of which is, when I'm walking, I deliberately notice the sensations of my body moving. All of the items are rated on this 5-point scale, ranging from 1, never or very rarely true, to 5, very often or always true. So the respondent chooses a number for each item and writes it here. Now each item by itself is an ordinal measure, so the question about noticing movement while walking is the ordinal measure. However, this instrument asks the researcher to calculate an overall score by adding all the responses together and to calculate 5 subscale scores for 5 different facets of mindfulness. This overall score and the subscale scores are considered interval level measurements. And once we have interval level data, we can do things like calculate the mean score on the instrument in our sample. Finally, and highest in our hierarchy, is ratio measurement. In this case, each number represents a precise amount, there are equal intervals, and there is an absolute or true 0 point. An example of a ratio measurement is age in years. Each number is a precise amount, and the space between numbers is the same in each case, 1 year. And it's possible to be 0 years old, as in the case of a newborn. Other examples are years of military service, number of children, and amount of debt. If you think back to our ordinal level measurement example of education, where we asked people to identify if they had completed high school, college, some college, or graduate degree, we could turn this into a ratio level measurement if we simply asked, how many years of education have you had? And then respondents could choose 0, 1, 2, all the way through however many years of education that they have. So how you ask the question may depend on the level of measurement you're hoping to use. Now, because of these features, we can perform all mathematical functions. In this case, it makes sense to say that someone who is 30 is twice as old as someone who is 15, and we can calculate the mean or average age in our sample and report that figure, so maybe it's 37.5 years. In this case, that figure has meaning. Now, one reason to always use the highest level of measurement possible is because you can always convert the data down a level, say from ratio to interval. But you can't convert up from interval to ratio. So if I ask respondents to report their actual income, This is a ratio level measure. I can then lump the data together into categories, say under 20,000, from 20,000 to 50,000, and so on, thus converting the data to interval measurement. However, if I initially use these categories, I wouldn't know the actual value of each respondent's income, so I couldn't convert interval level data to ratio level data. However, it's important to remember that in some cases we might prefer a lower level of measurement, such as when we have reason to think we're asking a sensitive question. Some people might be hesitant to write down their actual income, but may be willing to respond when presented with categories. Also, if we think people will have trouble recalling a precise amount, using interval categories can be helpful. To close this lecture, let's recap that we've looked at 4 levels of measurement: nominal, ordinal, interval, and ratio, with nominal measurement ranking the lowest in our hierarchy of observations and ratio measurement ranking the highest.